Good afternoon, all, for Toys4Engineers. This afternoon's round table think tank and talk is from Toys4Engineers, Automation, Robotics and Cobots. And I am delighted to have with us a panel of national and internationally recognized key opinion leaders, which I think will be able to fuel the debate on where we are, what challenges currently exist, and to where we can go in terms of automation and robotics, and what it means for all of our respective industries and for Ireland. So I would like to introduce you, first of all, to Brian Cooney, who's the Managing Director of KUKA Robotics, to Dan Buckley, who's the Managing Director of Cobots.ie and for Innovative Total Solutions, to Dr. Jonathan Downey, who's the Managing Director of Repligen, formerly Artisan Biosolutions, and also to Jerry Horan, who is the Managing Director of Horan Automation and Consulting. What I would first like to do is just go through to the panel and just, I suppose, very briefly for them, just to give a quick introduction to their area of expertise. And from then, I have a number of nice and easy, but also some very difficult questions to be posing to them. So I hope to get great energy and debate from here and insight again from these key opinion leaders. So first of all, maybe if I go to you, Jerry, just a brief synopsis of who you are, what is Horan Automation and Consulting, if you might have a couple of words to the couple of thousand people who've registered interest to this today.
Hi, Austin. Thanks very much for inviting me and welcome to the audience. Yeah, I'm Jerry Horan, Managing Director of Horan Automation. We basically design and manufacture bespoke automation solutions. We're generally based with robotics, and we're a system partner of one of the other guys there, Brian and KUKA. So basically, I suppose to explain, we take the KUKA robot and we put that into a cell of some description to do whatever needs to be done. And we also supply another line of equipment, mainly based around filling, capping, labeling, palletizing. So what we in the industry call end of line. So we have mostly the end of line, some production, and we work across all industries. So we work in food, pharma, healthcare, but our main thing, I suppose, is that it's bespoke solutions. So generally, when we build a machine, that's it. We only build one of them. We don't do another one.
Very good. So thanks very much. Thanks, Barry. So high value and high tech industry is effectively where you operate.
Yeah.
And I just realised I should have introduced myself as well as chair. I forgot altogether. Austin Coffey, Head of Department of Engineering Technology at Waterford Institute of Technology in the southeast of Ireland. And within that, we have a range of programs from level 6 certificate all the way up to PhD programs in the area of mechanical, electrical, electronic, automation, biomedical, manufacturing, engineering. And of course, automation is a key part to all those programs, I think, as we will find, based upon these expert backgrounds and some of the insights they have. Next, I would like to go to Brian Cooney. Brian Cooney is Managing Director of KUKA Robotics.
Yeah, thanks, Austin. I'm the Managing Director of KUKA Robotics. At this stage, I'm probably about 30 years, I guess, in the robotics and automation game. Prior to setting up the business here for KUKA in Ireland, I also set up the robotics business for ABB many years ago and ran that for a long time. So our market is pretty much all areas of manufacturing. And our route to market is through our system integrators and machine builders. So like Jerry, who was talking there a little bit earlier. But we have system integrators and system partners, machine builders, who would specialize in particular areas, so we might have some that might specialize in, like Jerry said, the end of line packaging, the 3Ps, pick, pack, palletize, or it could be in medical device, or it could be in metal fabrication and welding and so on as well. So we have a network of system partners throughout the country that will deliver systems, throughout those different manufacturing sectors. And as the robot manufacturer, I mean, we're one of the largest robot manufacturers worldwide. Yeah. And certainly we're the largest in terms of automotive and aerospace. There's other areas that are obviously, in an Irish perspective, much more important, since we don't really have an automotive sector, but medical device is very, very important to us here, as is consumer goods and general manufacturing, general industry, as we call it.
Great stuff. Thank you very much, Brian, for that. And if I might move to Dan Buckley, Innovative Total Solutions, and also Cobots.ie.
Hi, good morning. Good morning, Austin, and thanks very much for, I suppose for afternoon, for inviting us onto your panel this afternoon. Cobots.ie was established in 2018 as a result of a distribution need for collaborative robots. ITS is a company that we founded in 1993 to fulfill a need in electronics in the local market, and thereafter in the Irish market for pick and place and jigs and fixtures and that sort of thing. So we were the first company to bring Universal Robots to Ireland. Universal Robots is a Danish company, and they established the collaborative robotics market in 2008. So since then, we've installed over 330 robots in a collaborative fashion throughout Ireland and Europe. We're the only Universal Robot certified training centre in Ireland, and we offer core training and advanced training.
Fantastic.
Company itself, its core industries include metal and machining, that sort of thing, industrial electronics, life sciences, food, and plastics. So for those sort of industries, we provide a proof of principle. We provide like for concepts, etc. We provide mechanical, electrical, and certification right through to a turnkey solution through our company ITS, Innovative Total Solutions. So that's kind of a broad overview of how we do, and we're very proud that we can provide, we're a one-stop shop. We can provide a full turnkey solution, or we can provide just the robot and the fixturing that end customers might like to use. So a dual purpose kind of an idea.
Thank you very much, Dan, for that. And finally, I'll go to Dr. Jonathan Downey, who is Managing Director of Repligen. Thank you.
Thanks, Austin. Good morning, everybody. Yes, so I'm the MD of Artisan Biosolutions. We established our operations here in Waterford ramped up about 2.5 years ago. So we've about 4,000 square foot of clean room space, making single-use consumables for the bioprocessing industry. So there's kind of a couple of layers to what we do. At the Waterford plant, it's all assembly. It's liquid silicon rubber injection molding, sterilized drug flow paths that our customers, all the big drug companies, use to essentially allow quick changeovers. However, in our sites in California, we do make fully or almost fully automated biopharma systems, up to and including filtration, chromatography, those type of systems. So yeah, we were bought last year by Repligen, so there is the potential that some of those products will transfer in as well. Again, they're around deep biopharma filtration.
Very good. Thanks very much for that, Jonathan. So I suppose really we'll just start off for those of us maybe who are not wholly embedded in the automation and robotics side, but obviously somewhat are involved in it as part perhaps of our manufacturing processes, when we design parts for manufacture, and looking at, kind of getting the best out of whatever kind of industry we are. So I'm just going to put it perhaps to Brian, first of all. Automation and robotics, Brian, what is it?
So if we look at automation, within manufacturing, I mean, pretty much every single manufacturing process out there uses some form of automation. Whether it's a CNC machine with controls on it, whether it's a flow wrapper in a food producing environment, or whether, as Jonathan was mentioning in the bioscience, if it's a reactor skid, it'll have controls on it. So they all have some form of automation on it. Now, in terms of automation and robotics, that's where the machine is built, to carry out the manual processes that normally, would be done, by operators, but in a much more, cost efficient and competitive manner. So, you have machines, which are built, to purpose. They're bespoke machines, built to whatever the application, might happen to be, whether that's, folding sheets of metal, or whether it's, on a filling line for drinks, or whatever it happens to be. The robotics are then, they're installed on the machine, to do a lot of the handling and the processing tasks that normally, as I say, would be done by lines of operators.
Very good. Well, thanks very much. That's a very clear kind of background to that. And perhaps if I could just kind of follow up in terms of a keyword that Dan mentioned, it was about collaborative robots. And collaborative robots based upon automation, robotics, and even certain systems would be perceived as they can't be properly automated. Perhaps there's automation on certain aspects of it. What kind of insights, or can you actually explain what collaboration means in relation to robotics?
Is that for myself, Austin?
No, I was pitching that at Dan. Dan mentioned it.
Great.
Yeah.
It's from collaborative robots.
Yeah. Perfect. So I suppose the basic difference is that industrial robots are normally installed with a controlled environment, like a cage around them. So industrial robots move very quickly. They're strong machines, and there's a potential of if somebody moves in its way, there's a potential of harm. Whereas with a collaborative robot, it can be used with some forms of safety systems, but in general can be used outside the cage, and it depends on the system within the robot. So if it touches something or meets something unexpected, it stops. So the end-of-arm tools and the attachments to the robot need also to be manufactured with the idea that it's a soft stop for people, and that there's no sharp objects at the end-of-arm tools, so that if it meets that unexpected thing, or if it meets a person's arm, for example, there's no harm done. So it can be used for robotic arms, and we also use it for mobile robotics, where it's interacting with people, and it will stop if it's approached by a person, for example, and once that person moves out of the way, it'll resume its mission to complete its task.
Okay. Thanks, Dan. And I suppose, seeing that we're talking about robotics and automation here, I'll put it to Jerry. I suppose, in your opinion, as to where robotics have been, where they are, and maybe where they're going, what are the basic aspects when we talk about robotics and their key components? It's a very broad question, so you can lead it in whatever direction you want.
It's, I suppose, I'm along 20 years of this carry on, and the basic robot hasn't changed a huge amount. If you look at the robot now that it was 20 years ago, it hasn't changed a huge amount, except I suppose the technology and the connection with it and all that has changed and improved, and users interfaces has got easier. But the basic premise of the robot is still the same. It's, repetitive tasks that are difficult to do, and I suppose the fact that they're so long on the go, they are very economical. They've come down in price, really, or haven't increased much, even though I'd be giving out to Brian and scolding at him over the price of them, because we're trying to sell them on. But I have to say that they haven't changed much over the years. And so the basic robot is, I keep saying it's a great piece of equipment. And we're used to going in and selling these to people who don't kind of understand anything about them. And I suppose my my description always is that the robot is like the back axle of a JCB, because basically that's what it is. It's the way of doing. And our bit then is to design what goes on to the end of it and do the programming to tell it what to do. But so that's basically what the robot is, where it's going. That's the system it works. And from where we're at, I suppose our systems have kind of two bits. You have your robot in place, and then you have the rest of the automation in the cell. And the job is to try and tie them together, see what boxes are coming in, robot does its bit, and to kind of make it as easy as possible. Now, I have seen over the years that when we started at them, the customer was inclined to say to you, okay, put that in and make sure it's right and leave it there. Now we were getting much more that the operator needs to be able to get in, to interface with it, see what's going on, change it a little bit if necessary. So I suppose that the level of education of the staff is probably much higher now, and the training of staff is much more. In my early times, there was no one in the factory going near a robot. If it stopped, it would be called, okay, come in. But now, I think they're just becoming much more mainstream. Staff is getting much more used to them, much more friendly with them, and not nearly as afraid as they used to be.
So ease of flexibility, optimization, fit for purpose, and being able to adapt to change, of course, is all kind of inherent.
Yeah, very much so, and very much, I suppose, as well, they're going in now and they're on 24/7 operations, so they have to be sure that they don't stop, and if they do, you have to have someone available to get them going straight away. But no, there's much more of that, and the ease of operation. I suppose everyone is getting so much more used to touch screens and keypads, and that you have to kind of design your system a little bit similar then to what's happening with the rest of them.
Yeah, absolutely. Thanks, Jerry. And I suppose, Jonathan, in the era of robotics and automation, from your experience, how have they contributed, to maybe groundbreaking innovations, either in process or in product or services, and designs? How have they influenced from when you started off to where you are now, and to where you can see where you or the industry in which you're involved in, the pharma medtech, going?
I think Jerry made a very good point where he alluded to the fact that human beings are becoming more comfortable working around technology like robots and automation. And Brian mentioned CNC machines. I would have worked for a long time in the machining sector in medical devices. And over time, like 20 years ago, your machinist was the only guy that could understand what a machine was doing. But over time, I've seen it develop where there is that closed loop control on CNC machines. Now, don't get me wrong. You can't take human skill out of that process, but there is that increasing appetite to have a machine running 24 hours a day, and having the machine monitoring itself to a certain degree. Now, and again, I'll caveat that by saying you still need the human being skill. The challenge for me is that our processes are very, very manual. They're assembly processes. They're not massively repeatable. So, there is a fit somewhere for robotics and for automation in them. But ultimately, as Jerry said, you can't just drop a robot. If there's a robot being delivered tomorrow, so lads, all go home, you don't have jobs anymore. That ain't going to happen. You're going to need the human beings interacting with them. And I think that's the exciting thing about the notion of collaborative robots, because that was held back by, I can't remember the guy's name, Asimov, I think, where he made these rules of robotics, and it hamstrung everybody for years. But they're getting more clever, and they're getting safer and more kind of intuitive to work around human beings.
Brilliant. Well, you've raised a couple of points, and the four of you have raised a couple of points. I think that will be able to move this discussion to a different level. And maybe one of the key aspects, and we're just talking to again about perhaps the non-experienced person when they hear of automation, when they hear of robotics, they hear of all these new kind of nearly science fiction type words, and straight away they may kind of consider, well, how does automation affect the supply of labor? How does it affect where jobs are going to be created, or will these robots or big automated systems be taking our jobs from us? So I just put that actually to the panel, because that was You referred to that there, Jonathan, that absolutely is not the case. In an indirect way, I think. So I'll just put that to the panel here and maybe just see some of your views.
I'd say from my end of it, Jonathan or Austin, we always get that question when we go into a factory. It's not I want to be taking 3 jobs and 4 jobs, and we don't ever see it happening. If we're coming in normally, if production is increasing, you know, if production is staying the same as it is, they won't be automated. It's usually increasing production, so that's sort of. And a lot of times they just physically don't have the room to put 10 people in around the place, or now, I suppose it's getting more like they can't get the staff to do it. People don't want the jobs we're doing, you know, palletizing stuff onto boxes. People don't want to do that job. And anyway, you just don't physically have the room. And of course, last year with COVID and all that carry on in your 2 meter safe distance, and it's more and more that you just don't have room to stick people side by side. So, but we always get asked that question. Yeah. And as I say, my answer is always the same, that, you know, you have to, you can't put in the people there. And over the 20 years that I've been at it, I've always noticed the companies that automated 20 years ago are still there, and the ones that didn't aren't. You know, and it's just there's certain jobs, you know, you just can't get people, and you can't afford to do it. And it's gone too expensive. Like when I started, we were doing jobs where people were, you know, palletizing bags of coal onto a pallet by hand. But like, you couldn't pay people to do that now. Pick a bag of coal and put it onto a pallet. Just no one do it for you. And there's lots of other jobs like that. So that's always the same answer I have when anyone asks me.
Yeah, no, that's well said. Well said. If any comments, by the way, to any questions, please jump in with your opinion.
Yeah, I just, I mean, also just reiterate that as well. You know, I mean, it's the statistics actually show, you know, that economies, you know, that invest heavily in automation, you know, they grow, they continuously grow. It also provides the facility and it acts as an enabler for a lot of industries, you know, who might have, you know, in years gone by, you know, offshored their business, you know, to China or other low cost countries, which are no longer really that terribly low cost anymore. And it gives them the opportunity then to reshore and bring back on board a lot of the manufacturing that would have been subbed out elsewhere. So you actually do find that, you know, that companies that invest in automation and invest wisely in automation, you know, that their business continues to grow. They employ more people over a period of time, and the level of quality of the jobs that those people are involved in, you know, goes up demonstrably. You know, so you've got a much you know, better class of career, you know, coming out of, you know, highly automated plants. And you see that right across all manufacturing sectors.
Yeah. Thanks very much, Brian. And I suppose, as I said, that was one of the key points that I picked up just while I was just posing a couple of other questions to you. Indirectly as well, it was the aspect of, you know, some machines or some kind of automation systems, you know, they need to be able to adapt, perhaps communicate better to one and the other. And this brings me to the whole idea of machine learning, or perhaps a lot of people looking in at this may have heard of Industry 4.0 or 4.0, a phrase coined by Siemens. So I suppose just putting it to the panel, in terms of Industry 4.0, and just talking at this stage, because we will move on a little bit higher and into more advanced kind of terms and parlance, but Industry 4.0 or machine learning, what do you understand by that? And
maybe I could just interject there a small bit. So this kind of technology where machines are talking to machines is becoming the forefront of the reason why people are implementing collaborative robots and robots in general. So we supply, for example, some vision systems, which the vision system is talking to the robot and it's giving it the information to where the vision system has picked up a part, and it can identify exactly where it is with all the coordinates, and that information is transferred over to the robot. And now you can automatically pick and place components and in particular, small components which were really difficult for operators to handle. So we do one particular one which is called Azrael. We do another one which is called Picket, and that's a great system for picking parts out of a bin. It identifies the easiest part to pick, as in the highest part in the bin, the one that is the most identifiable, picks out that part, and the vision system then comes back in and it takes a new picture and will identify the next easiest part. So that automation and that type of system is becoming more prevalent in the kind of customers that we're coming across.
Great, Dan. And I suppose an add-on to that question would be, you know, the term itself a number of years ago, it was one of these newbie type terms. Industry 4.0, we're at the forefront, it's the new industrial revolution, etc. But really, how ubiquitous is it? Is it in as many companies, industries perhaps as it should? Is the area of Industry 4.0 machine learning and bringing kind of the whole communication of automation and robotics up to the level where it could be? If anybody has any points to make on that.
I might jump in there, Austin, and give you two examples. So it's a very sexy term and has been for a couple of years. But two examples that I saw of real adoption of Industry 4.0 is a company over in Belgium called Materialise. So we stood looking in the window of a room with over 100 3D printers, industry 3D printers, or industrial grade. No human beings were allowed into the room, and the machines completely controlled themselves and were being unloaded by robots. Fed out, as Dan said, using a vision system to do the inspection, and then packaged. The other one was a fantastic example in a company called Fresenius Kabi. So they make dialyzer filters, amongst other things. They have an enormous warehouse at Mirandola. And again, humans are not allowed into it. But they use drones to do the stock counting. This was about 3 years ago, so this is not new. They use drones to do the stock counting, and they use ASRS systems to pick the product. And the reason humans are not allowed in there, and this is kind of counter to what we're talking about with collaborative robots, is for safety, because the robots are doing all the work. There has been, and Brian will speak with far deeper knowledge of this, but there has been a lot of adoption within Ireland on that topic.
Yeah, brilliant.
Yeah, so just on that, I mean, so on the initial question, you know, I mean, is the level of adoption, you know, where it needs to be, and the short answer is no. So yes, a lot of companies have made great strides, you know, in introducing, Industry 4, you know, but part of the deterrent, you know, to it, you know, has been that the level of reluctance and a lack of understanding. So people have to actually understand, what does it really mean, you know, and they look at this big picture of a completely connected enterprise, you know, where your ERP systems are, you know, are talking down to your MES systems, and they're talking to the devices, and, you know, I mean, a robot just being a device, you know, on that network, you know. And then, you know, you've got artificial, you know, learning, and, you know, so you've got all these different technologies, and people look at it and they say, oh my God, no, it's too much. And if you look at it in the big picture, it is, you know, unless you've got lots of resources to be able, both in terms of manpower and in terms of cash, you know, to start implementing it, you know. But the reality of it is, any company of any size can begin to introduce Industry 4. Yeah, whether it's just a small packing machine or whatever it is, you just make sure that the connectivity is there to allow it to connect to other devices down the road, if you choose to go down further with it. But it's not that every company has to go with the big bang scenario and try and introduce, you know, a fully connected plant. They don't. You can start off as small as you want, you know, and grow as big as you want in terms of connectivity.
Brilliant. Thank you very much, Brian, and to all the contributors here, Jerry Horan, Dan Buckley, and Dr. Jonathan Downey. I suppose, I mean, a number of key, really, not just salient points, but points that I would like to kind of expand further upon have been raised here. The words AI, artificial intelligence, were mentioned, about the non-full take-up of adoption, how perhaps to further improve that. Could there be options perhaps for leapfrogging from one technology to the next based upon interaction with key opinion leaders like we have here, and also taking upon experiences of what we have here as well. Also, I would argue that we're going to go for a short break in a minute, but these are kind of things that I do want to look at. Industry 5.0, artificial intelligence, augmented reality, virtual reality, where they all actually fit into this picture, into the factory of the future, into industry of the future. And also as well, the upskilling requirements from industry, and from consulting training providers as well, as to where they see existing demerits are, where opportunities could exist, that collectively we could be making a call as an industrial and academic consortium as to actually what is needed to be fulfilling the needs, or rather unmet needs, of industry. So with that, I think we will take a short break, and Dean is going to play a couple of very interesting videos for a couple of minutes. Thank you.
Cobotics is the combination of the human and the robot interaction, so that the human and the robot can work closely together in a safe environment. The robot is totally safe, it's got sensors, it's not going to hurt you, and it can do tasks that the human can't really do. So it's absolutely fantastic technology.
Cobotics is the collaboration of robots and humans. It is the answer to future competitiveness within the marketplace. So I would advise any organizations that have processes, work processes that can be automated, should actively pursue that situation.
What this is bringing with it is immense potential, immense opportunity for enterprise, for businesses here in Ireland, and particularly small firms. But equally, it's bringing challenges in that tasks and jobs that were once thought to be the sole domain of humans are now being replaced by technology. But what unites both of those, of course, is upskilling, training, and lifelong learning.
It's the future. It's the future for industry, and it's where I think a lot of companies will be going in the future. So we can actually build the skills of our guys who come with their background in engineering, but we can actually get them to learn the skills on the job. We can actually build on their skills and tailor it to the type of business that we have.
Well, we see Cobotics being hugely important going forward. We see applications that are only possible with Cobotics. We see lots of applications that are only possible with industrial robotics, but it's opened up a whole new market. We hope to see them in a lot more factories going forward. We hope to see a lot of people thinking down the line of using Cobotics rather than standard industrial robotics or custom-built automation.
It's not a new industry. Robotics, separate from Cobotics, has been around for 30 years, and we've had long roots and a long relationship with them. In 2018, a cluster of companies came together and with the support of Skillnet Ireland formed the Cobotics Skillnet, and that has made a huge difference to the sector already.
Skillnet Ireland are really leading the forefront when it comes to upskilling people, training people, and I'm so impressed by how in the know they are. How that they are right there with the customers and knowing what Irish industry needs and what's very important. And one of those key things is people and the movement of people and the upskilling of people.
Knowledge is key, learning is key, education is key. We see Skillnet's hugely important for educating people that want to reskill, people that are currently in factories that need a little bit of education around robotics, or a bit of knowledge, a knowledge base, I suppose, and Skillnet is the key to that.
As one of the world's leading manufacturers and suppliers of advanced robotics and automation, we firmly believe that it's important, in order to serve our customer base, that we must act locally. For that reason, our facility here in Dundalk in Ireland is specifically designed around providing application support, service support, sales and training. In particular, we have a number of training cells here which cater on a weekly basis for our customers, for our system integrators and for our system partners.
Orange Intelligenz.
What does it take to make the world work? To stock our shelves, power our communities, care for those who feel pain, experience times of great joy. At Rockwell Automation, we make all these things possible. For all of life's moments, milestones, and celebrations, we are there, helping the world work better, faster, stronger, to be more connected and more intelligent. Because we know that when we combine the imaginations of people with the power of machines, anything is possible. Together with the world's innovators, makers, and problem solvers, we stand ready to lead the way, because that is where we belong. Rockwell Automation, expanding human possibility.
Good afternoon all again, and welcome to Toys4Engineers, hosted from the southeast of Ireland in Waterford. And we're back to the expert panel of automation, robotics and cobots. Just to briefly reintroduce the panel again to you, we have Jerry Horan, who is Managing Director of Holland Automation and Consulting. We have Brian Cooney, who is Managing Director of KUKA Robotics. We have Dan Buckley, who is Managing Director of Cobots.ie and also Innovative Total Solutions. And we have Dr. Jonathan Downey, who's Managing Director of Artisan Biosolutions. So I welcome the panel back. And prior to our short break, we were engaging on a very informative discussion as to what robotics and automation means, where it currently exists, keywords such as Industry 4.0 or machine learning and how they communicate with each other. And we touched on a number of aspects in terms of, you know, perhaps it's not as ubiquitous or it's not as taken up the benefits as much as we would expect. We've also learned as well that there are huge benefits from companies who have engaged in robotics and automation in terms of their sustainability, in terms of their productivity, and also in terms of their overall lifespan. So it really is great to hear these stories from internationally renowned key opinion leaders in these areas. But it was mentioned just a couple of times about, you know, artificial intelligence, stuff that was absolutely science fiction, certainly when I was growing up, and I'm not that old yet. You know, but it seems to be around us in terms of research areas, but where is it in terms of what does it mean, artificial intelligence for robotics and automation? And it's a leading question. Perhaps I'll just go straight to Brian Cooney, maybe just to talk about his perceptions of what it is, what this phrase of Industry 5.0 may actually involve as well, and what it means for industry as we know it today.
Yeah, well, artificial intelligence, you know, or you know, self-learning, you know, is effectively really what it is.
Okay, very good. And I suppose, you know, so that's the kind of increased intelligence, increased learning capabilities of machines and systems as we have. And the artificial intelligence side, to the best of my knowledge, from my limited experience, often includes experience, which is kind of the very, very difficult to identify or to contextualize factor, I suppose, that comes directly from traditional machine learning up to the next level, which is artificial intelligence. Would anybody have comments to make about that? Again, we could be spanning multiple industries here when we use these terms, so they could actually mean a lot of different things.
Well, we're seeing the next level of it at the moment. You know, we're noticing with this augmented reality, and you're set up now with your 3D glasses on you, and an operator can go and look at this, see what's going on, see in the corner of his eye how the it's being, and then someone in the background, looking at another screen and saying, there's a problem, move that, check that. And for us, that's a big change now. We've noticed even during the COVID again with the lockdown and FATs and inspections, you don't need to have 10 people out on site looking at something. One guy there can do it. But that's a huge change. Like a few years ago, you would never be able to do that and see.
And Jerry, just to kind of focus on that, even because this is a huge step change. This is leapfrog kind of technology. And what you're saying is that it's not necessarily somebody beside the other technician or beside the engineer, but that person could be actually on a different continent.
Oh yeah,
servicing that. Yeah.
And I suppose the big there's two things really driving that, and two things making it possible, and access to internet and good broadband are the two things. If you don't have that, you can't do it. But we do a good bit of work in China. Like we've been able to do FATs on a machine in China with someone there. We here in the factory here, our customer in their factory, and they all looking at the same thing, and they all talking and saying, okay, wait, now turn around, do you see what's over there? Did you catch that? Where? It's almost, now it's not exactly as good as being there, but it's definitely an awful lot easier than traveling to the other end of the world to look at something.
No, it's incredible. I know certainly my own experience, injection molded machines, next generation, you can actually advise and actually click at what needs to be done on that machine from many thousands and thousands of miles away. And of course, emerging technologies and successful applications, certainly in the medtech and clinical surgical area, have also involved similar AR and VR aspects with robotics at the other end of the line. Sorry, Jonathan, you were just about to...
I was just going to say, Jerry, that's a great point. We've been working for about the last 12 months on an augmented reality program. There's a consortium in Ireland working on it. And the initial thing for me was that you could use augmented reality, for example, in an assembly. If you try to plug it in at the wrong end, it goes red. And if you plug it in at the right end, it goes green, right? But then when COVID hit, we were flying people all around the world to do FATs. And we've been doing them remotely with augmented reality. And it's, as you said, point well made, it's not the same as being there, but it's getting pretty close. So that was, we started the project going down the route. I was convinced that the killer app was foolproofing assembly techniques. But then COVID came and we realized, it's remote FAT. So I think that's a really, really emerging technology, and it's really getting there fast.
Lightning. And Dan, have you any insight that you might want to share in terms of your insights, either practical experience or where you view this kind of artificial intelligence and or the AR VR component of added onto robotics and automation?
Yeah, so we found much the same as Jonathan there now. Recently we've done some installations in Germany and in South Carolina, for example, where we've manufactured the machine here. We do a pre-factory acceptance test here, and with everything working well here, we can ship it, and the customer can actually install it. And with the aid then of good broadband suggested by Jerry, and connectivity to the machine, which is the most important thing, we can see real time what's going on in America and adjust it accordingly here. And we've managed to install a number of machines in that fashion, which wouldn't have been possible before without the Industry 4.0 and the connectivity and being able to see the sensors and look at the vision systems. And I think that's most important coming out of the courses that you're supplying down there, Austin, is the mechatronics aspect of it, the AR, VR aspect of it, and I feel myself the UX, DX aspect of learning is most important for students to get their head around that and to come into industry with all that knowledge, and which will be very beneficial to guys like me who are always learning. If there's someone there who comes out and who already has that knowledge, it's a huge benefit and makes them much easier to employ.
Absolutely. I absolutely agree and concur with what you're saying. I mean, certainly in Waterford Institute of Technology and our programs, all our programs actually at degree level and beyond, but in the Department of Engineering Technology has those key modules of which you referred to, and they're shared right throughout so that everybody does get the same chance at it. Often in terms of education and looking at all our profiles here, who would have predicted, 10, 15, 20 years later, we would have been in what industry at what level, but at least it gives, kind of good kind of running speed for graduates that actually are able to embrace the key concepts, the key languages, the key interactions required, whereby effectively robotics and automation are here with all of us, irrespective of the industry nearly in which we operate in. So absolutely. And we'll talk about the education requirements, the upskilling, perhaps the lack of qualified people. And is that perhaps the biggest limitation factor that we're seeing against the multiple industries going forward? But before I get into that, the other kind of key word which comes up quite a lot, and I might put this on to Brian again, if you don't mind, Brian, being in the firing line, but digital twin. It's a new phrase coined. Can you explain, perhaps, in your opinion, what digital twin means when it comes to robotics automation and the future of where we are?
Yeah, so when you look at digital twin, and simulation has been around for a while, and effectively to some extent, digital twin is an evolution, of simulation, whereas instead of designing something up on a simulation package which replicates what you want to build, you're actually virtually building your machine. So your machine is running in real time as the hard machine, if you like, would also be running. So it's very, very useful tools, to machine builders, line builders, and so on, because they can design out the full machine. They understand the efficiencies of the machine. They're communicating. They're creating all the coding, in the virtual twin, in the digital twin. So when they make a change to one part of the machine, they can see the effect that it has on the rest of it, and that's before you ever cut a piece of metal. So when you cut a piece of metal and you build a machine, then you can run your virtual twin forever alongside your main machine, your actual physical machine. Yeah. So it's something that's been around in terms of as I say, the simulation side of things for quite a number of years. But over the last number of years, it's taken on a whole new meaning, whereby, as I say, you can build your virtual machine, you can digitally, and virtually commission it. So that has huge benefits for everybody, right from the designers, right all the way through that, as I say, when it's actually finally installed on the production floor, and you have your virtual machine, living alongside the real machine.
Fabulous. It's fascinating. It's bringing, I think, what we would have had previously, as you say, kind of digital scenario-based kind of designs and modeling, but to the real sector. So kind of making the theoretical practical, or making the theoretical pragmatic rather, and being able to preempt fault finding in real time.
Yeah. So what you're doing, is you're taking your concept, your theory, and you're building it, in a safe environment. Yeah. So you haven't built the machine, and in a lot of cases in the past, machines have been built and failed.
Yeah.
The reality just didn't meet, the theory.
Yeah.
In this case, you're building it virtually. So there is no failure. You build it virtually, and if it's not right, you change it.
That's fantastic. That's really that's again, this isn't it a great age in which we're all living in. Science fiction of the past is actually reality of the present. Not to mind the future.
The other big advantage as well we're finding with it, Austin, is we're dealing more and more with companies who maybe they don't have us highly skilled engineers at the top of them and can't understand all. And it's much easier when you're explaining to, you know, finance people, health and safety people, production people. If you have the virtual machine there, it's much easier to get the whole concept together and get it through to them before ever. Because we would often have found, you know, we would be dealing with engineers, and maybe when you arrive on the floor then with the machine, the production guy or the health and safety guy, someone would spot something and say, "Oh, we can't have that." And they can't really, you know, if you're not from an engineering background, it's more difficult to see what's going on while the machine is in concept stage. But now we're finding much less of that. Everyone's able to look at it. Everyone's able to have their opinion. And again, it's almost the same as seeing the real machine there. Only it's in time, if they have some, you know, something they don't like about it, then it can be changed before you ever start that. And that's like we're finding that more and more people we're dealing with are, you know, it's not engineers, it's finance people, it's marketing people, it's production people, and they're not used to looking at drawings and 2D drawings.
So often, like while earlier we were talking about communication between machines and different platforms, really at the end of it, what this digital twin can also do to a very effective level is to help and manage communication between ourselves and between different business units so that everybody is on the same page and expectations can be managed.
Yeah. This is also where your VR comes in, Austin, because, you know, you have your digital twin, you know, and, you know, so you can walk your machine.
Yeah.
You know, you can see how you can get operator acceptance because the operators can walk the machine. They can identify where there's ergonomic issues and so on, you know, and that's just all in a virtual world, all in the cloud.
That's fascinating stuff. Fascinating. And I suppose, so we're talking about, you know, so where the whole idea of what is a robot, what is automation, we brought it up to, you know, where we are now, where we are going. But technology and the technological convergence is happening at such, you know, a light speed rate. You know, I would only kind of peruse that or think that, you know, to think of where robotics and automation maybe in the next 10 to 20 years, you know, is, I suppose it really is, you know, the border, the limits are the borders of one's imagination, perhaps. I'll just put it to the team, you know, where do you think we are going with all of this? So we have phrases, Industry 4.0, Industry 5.0, we've artificial intelligence, we've virtual reality, augmented reality, we've things called digital twin. So where do you, whoever wants to jump in here, you're more than welcome.
So I'm jumping to answer that one because we're sure to be proven wrong, whatever we say.
Of course, yeah. But, that's the function.
Yeah, it's hard to actually see to visualize where it's going over the next number of years. Like it will keep progressing in the line of automation, getting things done, less people, more exact stuff. That will just happen. There's no doubt about that. But I suppose the 3D printing is something at the moment, and if another version of that comes in, that will make the manufacture of the bits and pieces much easier to do. And whether there'll be a newer version of something like that can just take your drawing and your piece made. That we're close enough to that at the moment with some of the production stuff in that you can draw it up and it can be more or less turned out. But it's just, it's hard to figure. Like I would say, whatever is going to happen in the time will be the cloud and wireless communication. Like wireless communication will be a big help if we can get, because I suppose in our job at the moment, one of the biggest ends of it is actually the physical wiring and connecting and plugging stuff together. And if that could be automated and advanced, then that would make a big difference, because that's time-wise between doing your electrical drawings, wiring and numbers, that's still a very physical and labor-intensive part of the whole process of putting a cell. And if that can be reduced, that would make a big difference.
And even, you know, the whole idea of reducing footprint, you know, from the days when laser printers were unattainable by anybody, but everybody has them. You know, 3D printers the same, but if you want them, you have them. The evolution of them going into personalized medicine based upon, you know, one's by a genome and all this kind of thing, the interactions, communications, how they're actually all coming together, is more than interesting, and I think it's important to, to try, if at all possible, to be one step ahead. But I think it was also mentioned throughout here that, we also need to plan for what we actually currently need and address the key deficits. So I suppose really where I'm going on here is the absolute need of upskilling, training, to have personnel at all levels, I suppose, ready and enabled for this. It's not really an industry. You can't call this an industry because it spans all industries, in my opinion. So maybe if I just start maybe with Jonathan. I mean, Jonathan, you came from a background of, electronic engineering, and then you did manufacturing engineering at Waterford Institute of Technology, and then, went many different places throughout your career, and had many kind of stepping ways. But notwithstanding, you're here today as a key opinion leader in terms of both how you use automation, control, robotics, but also in terms of the business implementation side and where new opportunities can be created. So from your perspective as a large-scale employer and from your previous experience, might you be able to address, I suppose, the unmet...
Yeah, I was gonna dive in there, Austin, and I'm kind of on the... I'm not going to...
Yeah.
Well, I agree to them that the regulation is killing a lot of automation. We find it in particular in the healthcare and pharma that there's people there mad to do things, but they just say, yeah, it'll pay for itself, it'll do the job fine, but we'd never get it validated. And it kills me because you think, oh, it's a terror to have, new technology that can do everything right. And then just because it can't be validated or it's very difficult to get it validated, then the thing doesn't happen. And that is an issue. I don't know, as you say, it's definitely COVID has shown that you can get around it, but it is an issue. It's stifling an awful lot of what's going on. And I would even say for Dan there with the cobots, probably a bit the same. You know, because he's in another industry and it's, you know, that bit new. I'm sure he's finding the same pushback for things that aren't really logical.
So, you know, companies are slow to change, and if there's a validated process, then it takes a lot of time to move that to a new process, and that's where companies are hesitant to take on the new technologies. So I agree with Jonathan wholeheartedly in that you need to produce champions of technology coming out the end of your educational process to bring the new technology into companies like ourselves, but more like the end users to bring it into that sort of environment and get them to be the early adopters then for that new technology. So yeah, I agree wholeheartedly, Jonathan.
Thank you, Dan. And Brian?
Yeah, so I mean, I agree across all of Jonathan's points. I think one thing I would add to the regulatory discussion, you know, is that you know, a lot of the problems around regulatory, you know, one is the governing bodies, you know, that are in control. So the likes of the FDAs and the medicine boards and whatever else, you know. And traditionally, I think, you know, it'd be fair to say that they had their head in the sand as far as this was concerned. They didn't want to change. You know, I think there is a groundswell of change imminent, you know, within these industries. I think regardless of whether it's, you know, medical device, automotive, pharmaceuticals, whatever else, I think there's a growing realization, you know, that the adoption of automation in general, you know, is a good thing. Yeah. And I think then that, you know, for a lot of companies, when they're looking at introducing automation of whatever kind it might be, 3D printing or whatever else, you know, I think it's incumbent on them, and they are doing it now, you know, is that they bring the people who are responsible for the validation on that journey with them, as opposed to, you know, dumping it on them and say, guys, now validate it, you know.
It's a journey, correct.
It's a journey, yeah.
It is indeed a journey. And I suppose finally, I'm just conscious of the time here, but it has been a most engaging discussion. I suppose just ultimately, from a personal point of view, acting across pre-academia, and while I do fortunately have at least one and a bit feet still heavily in some of the high value sectors industry-wide, one key thing, regardless of automation, robotics, kind of optimization of control, communications, is simply lack of people. So, you know, I think there's really no key way, you know, to circle that square. Other than that, perhaps just kind of continuous promotion of the fact that there are really, really outstanding careers available at all levels to people who focus into these areas, and also kind of collaborative training programs, and maybe, you know, with the key universities augmenting their delivery programs to work with people who are in industry, so that, you know, there can be kind of engagement back to the company or on continuous basis. So there's I think a little bit of maybe innovative free thinking perhaps also needs to be put in place in order to address these absolute crying out demands.
If I might just add there, now the new advancement of the apprenticeship programs and the bringing that into the mainstream has been, and I think we'll reap the benefits of it in the future, but it's a great advancement for the universities and the institutes of technologies where you know, they can do part-time in college and part-time on site, and you know, it's a fantastic new development in recent years.
Yeah, hopefully it's just the start of something greater to come, such as the Global Campus Initiative, which has been led throughout a number of different countries, specifically for addressing key skills shortages. But with that, again, we have gone over time, but I would really, really like to thank our panel members here. We have Jerry Horan, Managing Director of Horan Automation and Consulting. We have Brian Cooney, who's Managing Director of KUKA Robotics. We have Dan Buckley, who is Managing Director of Innovative Total Solutions and Cobots.ie. And we also have Dr. Jonathan Downey, who is Managing Director of Artisan Biosolutions. Thank you very, very much, Acharda. It was really, really great having you here. And I think it has really addressed where we are, where we want to go, and the future opportunities as well as limitations to all our industries in the field of automation and robotics. So thank you very much. And with that, I will head back to the Toys4Engineers, but it is very important for me to say as well, having this web-enabled worldwide conference hosted online from Waterford. Waterford has just been voted and awarded the best city in Ireland to live. Now, coupled with the fact that Ireland is one of the best countries in the world to live, it logically follows that Waterford is one of the best places in the world to live. So thank you very much. And any questions or correspondences, I'm sure you'll be, we would all look forward to engage at future dates through panels such as this. Thank you indeed. Bye-bye.
I think the word cluster is very, very important, because that signifies to anybody that's looking to come to the Southeast that there are other opportunities for them. There's over 100, I believe, tech companies at the moment based within Waterford and in the Southeast region. That, as well as a wonderful quality of life, the fact that there were so many opportunities and so many different global companies within Waterford that people could move around. Waterford, find your future. It's a very realistic statement to make. We've now managed to grow and scale our business to a staff of over 60, and we've done all that based within Waterford. So there most definitely is a future for companies or for people if they choose Waterford as their base.
You know, there's so much here, like it's, you know, I feel very fortunate to be living here. Tremendous support. We've great staff, all local, and it's just, yeah, it's a great spot to live. So I was born and bred here and lived in a lot of places around the world, but was fortunate to get to come back to Waterford and continue our family business. It's a fantastic place to live. You know, we're 4 miles from the sea. You've Tramore, Dunmore, you've the Cumra Mountains.
We employ about 800 people here in Waterford. The company is about 100,000 people worldwide. Why was Waterford selected? It's a great location, good infrastructure, road and rail for both people and product. It's cost competitive, but mostly we came to Waterford for the people. In terms of bringing up a family, Waterford has a huge amount to offer. Great schools, both junior and senior cycle. Waterford is Ireland's best kept secret in terms of quality of life.
Waterford has certainly been a pivotal part of the company's success. We kind of often joke locally about it being an unkept secret. We're working with some of the top health systems in the United States. We've got quite a diverse population in Waterford. We as a company have employed people with multilingual expertise, speaking multiple different languages. Waterford people have a very strong work ethic, have great communication skills, good problem solving skills. Find your future in Waterford. I think there's lots of opportunities, whatever your interests are, if it's sport, if it's the music scene, if it's the cultural scene. We've got all of that in abundance, so I think, Waterford, it's a good place to live, work and, actually grow your career as well.